We are going to review the mechanisms that operate in the lithium adsorption process in brines. This video contains a black band that contains the Spanish translation of my comments and explanations. Let's summarize the content of this presentation. In point 1, we review the definitions of adsorption and absorption process. In point 2, we present a molecular vision of liquid water. In point 3, we present a molecular view of aqueous ions lithium and chloro and salt of lithium chloride. In point 4, we present a molecular view of LDH-based absorbent systems, also known as double-layer systems. In point 5, we present the mechanisms that operate during the lithium extraction process in brines. We begin to review point 1 of this presentation. The difference between adsorption and absorption is shown. Adsorption is a process that operates on the surface of a solid. The molecules accumulate on the surface of the adsorbent. By the other hand, adsorption is a process in which molecules enter into the bulk of the solid. Next, we will review point 2 of this presentation. Here is the molecular vision of liquid water. Liquid water is a three-dimensional network. The nodes of the molecular network are the water molecules. The force that holds water molecules together is called hydrogen bonding. The blue arrow indicates a hydrogen bond that operates between the oxygen of one of the water molecules with the hydrogen of the other water molecule. We ask the following question: how many molecules are needed to generate a molecular representation of liquid water, capable of reproducing all its properties? In particular, we are interested in generating a molecular model that can reproduce the enthalpy of evaporation of water. In figure 1, we have the molecular model for representation of liquid water, using a large number of water molecules. However, from the point of view of computation chemistry, it has a huge cost of computation time. In figure 2, we have a cluster of 16 water molecules, which is a model of liquid water that is capable of reproducing the key properties of liquid water. In this case, the enthalpy of evaporation of liquid water. In figure 3, we have a pictorial representation of cluster in figure 2. The objective of this symbolic representation is to present in a simple way the reaction mechanism of the lithium extraction process. Next, we will review point 3 of this presentation. Here we have a molecular view of the chloride ion in the aqueous state. The aqueous chloride ion can be represented pictorially in figure 2. The blue circular band in figure 2 represents the hydration shell of the chlorine ion. In this case, the blue band contains a minimum number of water molecules, such that it allows to reproduce a key property. In this case, the model reproduces the solvatation enthalpy of the chloride ion. The aqueous lithium ion can be represented pictorially as we see in figure 2. The circular band in blue color represents the hydration shell of lithium ion. Here we have the molecular view of a lithium chloride brine. The model of figure 1 for lithium chloride brine can be represented in a more compact way by the model of figure 2. Notice that the model in figure 2 can be generated by joining the models of aqueous lithium and chloride ions. Next, we will review point 4 this presentation. Here we have the molecular vision of adsorbent agent for selective adsorption of lithium in brines. The model of figure 1 for LDH adsorbent can be represented in a more compact way by the model of figure 2. Next, we will review point 5 of this presentation. Inside the red box are the symbols used to represent the basic structures we have developed so far. Species 1 is the molecular structure of LDH type adsorbent, which is saturated with lithium ions. Species 1 is contacted with aqueous hydrochloric acid. See species 2. The reaction of species 1 with species 2 produce species 3 and 4. Note the positive proton now occupies the space where the positive lithium ion was previously within the adsorbent extractor. Species 2 and 3 are put in contact with enough water, and the active species 4 is generated where there is a positive lithium unsaturation, which we have indicated with a yellow circle. This unsaturation is actually a vacancy of positive lithium. The species 4 is put in contact with a brine of a diversity of ions, and the species 1 is generated, and we have closed the circle on the adsorption process. Finally, we have finished this presentation. Thank you for your time.